Hey, welcome back to Distance Learning. It's Mr. Leong. We're going to factor some trinomials today. All right, so in your notes, which you got off the school website, there's kind of like a list of 5 steps and then some examples. Okay. Now, since we've already learned how to factor trinomials, I'm not going to write out a bunch of small steps. I'll just kind of break it down into 2 steps for you. Okay, so step number 1, you're going to factor out a GCF, a greatest common factor, if it exists. Okay, not every polynomial is going to have a greatest common factor. Okay. And so this is kind of like an optional step. You may or may not need to do it. Okay. Step number 2, which you're going to do in every one of these problems, is you're going to use the area model, which we often refer to as the box method. Okay. All right, remember the box method or area model is what we used to multiply a polynomial with another polynomial, and it's also what we use to factor, which is a fancy way of saying divide polynomials. Okay. All right, so we've got a couple example problems and some U-try problems. So we'll kind of use the same format as the last video. I'll do the example, you pause the video, try the other problem, and then unpause to check your answer. Okay. All right, so let's go ahead and set up our area model. Okay, the squared term goes in the first box, the constant goes in the last box, and then those 2 empty boxes on the diagonal, right, we're going to write ourselves a couple clues, right? Clue number 1 is that these have to add up to the middle term 9x. Okay, so it has to add to 9x. Clue number 2 is that these 2 terms have to form the same product as these 2 terms. In other words, it's going to have to multiply to make 20x squared. Okay, so you're going to do some mental math, or maybe on a scratch piece of paper, just kind of guess and check. But in the end, you should find that the 2 missing terms are 5x and 4x. Right? Those add up to 9x, and if you multiply those, you get 20x squared. Okay. So now that we've completed the inside of the box, we're going to figure out what are the factors that go on the outside of the box. Okay. Now, if I look at just the top row, right, x squared and 4x, well, they both have an x in common. Okay. And then now I can just figure out, well, what factor would I multiply with x to make x squared? Well, I need another factor of x. And what factor would I need here to make 4x? Well, I need a factor of 4. Okay. And then let's figure out this last factor. X times what makes 5x? Oh, x times 5 makes 5x. And then lastly, check 5 times 4 makes 20. Okay. So these terms on the outside are going to be the factors of the polynomial. We'll write it here. Okay, so there's going to be an x plus 5 factor and an x plus 4 factor. Okay. All right, so look at U-try number 1, pause the video, try it yourself, and then we'll check answers. All right, so we've got a lot more space here. I was worried that first problem I was going to run out of space. So let's do x squared in the first box, 16 in the last box, and then we're going to write out those 2 clues. Okay, so those 2 empty diagonals have to add up to make 10x, and it's going to have to multiply to make the same product here, which is 16x squared. Okay. So let's see, what could it be? 4x times 4x? No, that's not going to make 10. 8x and 2x? Yeah, that's it. All right. Let's go ahead and fill it in, and then now work on completing the outside. Okay. So x squared and 2x, what they have in common is a power of x. Okay. And then we need another factor of x there to make x squared. We need a factor of 2 there to make 2x. And then we need a factor of 8 there to make the 8x. And yes, 2 times 8 is 16. All right, so x plus 8 and x plus 2 are going to be our factors. All right. Oh, but you got something different? What did you get x plus 2 times x plus 8? It's possible, right? These are actually the same answer, right? In math, the order of multiplication doesn't matter, right? So you can rearrange the order of these two factors and it's still considered the same answer. Okay. All right. Let's look at example 1, part B. Okay, so now that there's a coefficient here, I'm going to pause and see if maybe I need to factor out a GCF. Okay, but then I see the next number is 13. That's a prime number. So I don't think, well, I know there's nothing that can divide 2 and 13 and 15 other than 1, but we never use 1. All right, so we're just going to go right into our box method. All right, so 2x squared, first term, first box, 15, last term, last box. Okay. And then clue number 1 is that these two empty boxes have to add to 13x. And they've got to multiply to make the same product here. So 2 and 15 gives a product of 30, and it's going to be a second power of x. All right. So the good thing is that all the terms are positive, so we're not having to worry about negatives at the moment. Let's see, what are all the ways we can make 30? 30 times 1, 2 times 15, 3 times 10. Oh, and 3 and 10 add up to 13. Okay, so we can write 3x and 10x. Okay. All right, so what I like to do here is just look at the first two rows, the first row, right, and see what these two terms have in common, right? They're both divisible by 2, and they both have a power of x. Okay, really what I'm doing here is I'm finding the GCF of these two terms. Okay, so now that I know that this factor is 2x, this factor has to be x, right? It's the only way to get 2x squared. And this factor has to be 5, right? 2x times 5 is the only way to get 10x. Okay, and then now let's figure out the missing factor here. Since this is an x, this has to be a 3. Right, to make a product of 3x, and then 3 times 5 is 15. All right, so 2x plus 3 is one of our factors, and x plus 5 is the other one of our factors. All right, take a look at you try number 2, pause the video, work it out, and then we'll check answers. Okay, so 3, 10, 8, do not have any common factors among them. So we're just going to go right into our box method. First term, first box. Last term, last box. Okay, our two diagonals will add up to 10x, and at the same time have to multiply to, let's see, 3 times 8. That's going to be 24x squared. Okay, so let's see. This one came pretty quick to me, 4x and 6x. Right? Those add up to 10x, and when you multiply them, you get 24x squared. Okay. So our first row, what those terms have in common is 3x. The missing factor here is x, and the missing factor here would be a 2. And then if this is an x, then this factor out here has to be a 4. And then 4 times 2 is 8. All right, so the factorization is going to be 3x plus 4 and x plus 2. All right, hope you're sticking with me. We've got a few more problems on the next page. Okay, so now we're looking at some negative terms. Okay, the overall process stays the same though. All right, so we're going to move a little bit more quickly here since we're not really doing anything new other than the signs. Okay, first term, first box. Last term, last box. Okay, write out the clues. Okay, it's got to add to negative 10x. And it's got to multiply to make 24x squared. Okay. Now you might have to go through a bit more trial and error here because of the negative signs. Let me think about this. Let's see, 24 could be 6 and 4. Yeah, so what about negative 6x and negative 4x? Okay, if we add those, it makes negative 10x. And if we multiply them, remember, a negative times a negative is a positive, which is exactly what we're trying to make there. Okay. All right, so then our first row, what they have in common is an x. And so this factor would need to be an x to make the product x squared. This factor would have to be negative 4 to make the product negative 4x. Let's see, x times negative 6 is how we get that product. And negative 6 times negative 4 is positive 24. All right, so we've done it. X minus 6 and x minus 4. That's a 4 there. All right, let's do B, and then we'll go to the U try. Okay. All right, so again, set up our area model. First term, first box. Last term, last box. Don't forget the signs, right? So that 10 has the negative sign attached to it, so it goes there. All right, our two missing terms have to add up to the middle term there, which I'll actually write the negative 1 there. You can always put that coefficient in. Okay. And then our two missing terms have to multiply to make the same product here. So 2 and negative 10 makes a product of negative 20, and then there's an x squared on it. Okay. All right, so in the first example, I didn't really show you how I ended up with the negative 6 and negative 4. So here, let me show you what trial and error might look like. Okay, so we know we want to make a product of negative 20, right? Let me not worry about the negative sign right now. Okay, so what are all the pairs of numbers whose product is 20? Well, 1 and 20, 2 and 10, and 3 and nothing, 4 and 5. Okay. And so now I can start looking at just these pairs of numbers and, trying to include negative signs in a way so that it multiplies to negative 20 and adds to negative 1. Okay. So now I know that I really want the product to be negative 20. So no matter where I put a negative sign here, there's no way it's going to add to negative 1. So we can rule that out. No matter where I put negative signs here, it's not going to add up to negative 1. So we can rule that out. Okay. Now we got to figure out where to put the negative sign on these numbers so that it adds up to negative 1. And it would have to be the 5 that's negative. Okay. And so that means that our two missing terms are going to be negative 5x and positive 4x. Right? And you can check. Those add up to negative 1x, and they multiply to negative 20x squared. Okay. All right, so now we've filled out the inside of the box. Let's get the outside factors. Let's see, the first row has in common a factor of 2 and 1 power of x. And so we would need another factor of x on top of that column and a factor of 2 above that column, right? 2x times x makes that term. 2x times 2 makes that term. Okay, and then x times negative 5 would make the term in the bottom left, and negative 5 times 2 makes negative 10. All right, so our factorization is 2x minus 5, and then an x plus 2. All right, here's the U try that goes with these examples. Pause the video, and when you're ready to check your answer, unpause. Okay. All right, so we're going to jump right into it. 3x squared negative 20. All right, our two missing terms have to add up to 11x, and we'll have to multiply to make negative 3 times negative 60 x squared. Okay, so hopefully you made like a factor table like this or maybe you just figured out what the terms are in your head. I'm trying to work it out right now. Let's see, 60. You know, I might have to go to a table. Right? It's not coming to me right away. All right, so 60 is 1 times 60, 2 times 30, 3 times 20, 4 times 15. That's looking pretty enticing to me, right? Because I know if I do 15 minus 4, that would be 11, right? So would that work? Would that multiply to, yes, figured it out. Okay, so we'll do a negative 4x and a 15x right there. Okay. All right, so top row, what they have in common is 3x, so need a factor of x there and a factor of 5 there. All right, 3 times 5 is 15. And then the only other factor we would need then is the negative 4. Okay. All right, so 3x minus 4 and x plus 5 are the factors of our polynomial. All right, so if you stuck with me this long, thank you. We've got one more example and another you try. Yeah. All right, so what is the one thing we have not done yet, but was part of our step-by-step process, was to factor out a GCF. Okay. So if you look at example 3, look at your coefficients, 3, 15, and 42. Okay, so those are all divisible by 3. Okay, and that's going to leave us with x squared plus 5x minus, is it 14? I better check. Don't want to make a mistake. 42 divided by 3, yeah, it's 14. Minus 14. Okay. All right, so right away, we know that 3 is going to be part of the factorization. Okay. But the rest of the factorization is going to come from performing the box method, or the area model, on this polynomial. Okay. All right, so x squared minus 14. Okay, we need to find terms that add to 5x and multiply to make this product here negative 14x squared. Okay, there's only really few ways to make 14, 7, and 2, right? So let's just go ahead and put 7 and 2 there. Now, to make it add up to 5, I guess the 2 would have to be negative, and because this is a 5x, then my terms need x's on them. You knew that already. All right, so top row, those terms only have an x in common. This product would need another factor of x. To make this product, we need a factor of 7. And then we would need a factor of negative 2 to make the product of negative 2x. Okay, so we're going to have an x minus 2 as a factor and an x plus 7 as our other factor. Okay. So just to recap, the only thing new here is that we had to first divide out the GCF, the greatest common factor, right? Okay, so go ahead and do the you try, pause the video, and then I'll go over the answer once you unpause. Okay, so did you figure out the GCF? Okay, well 2, 12, and 16 are all even numbers. Okay, so they're all divisible by 2. We're going to get an x squared plus a 6x plus an 8. Now, what a lot of students forget to do is in their factorization, right, in their final answer, they forget to write the greatest common factor. So just to save that headache now, let's just write it in, right, before we forget. Right? And because we are recognizing patterns and structure, right, we know that we're going to have 2 binomial factors. So I'm just going to write some empty parentheses there. All right, I'm liking this problem because all the terms are positive. Okay, and there are relatively small numbers, so we should be able to make quick work of this problem. Okay, Our two missing terms need to add to 6x, right? That's the middle term. And it has to multiply to make 8x squared. Okay, so 4x and 2x. That's all I can think of. All right, so we're going to have factors of x outside of the x squared box. We'll need a factor of 2 there and a factor of 4 there. Okay, so x plus 4 and x plus 2. And we did it, right? We worked through all those trinomials and we factored them all. And the kind of commonality is that we use the box method or the area model. Okay, very powerful tool.